Our conversation about Python lists would not be complete if we did not mention a feature called list comprehension. So let's open our next sample file that's called video 8.3 comprehension and see some examples. So list comprehension is a syntax to create lists from a string or another list, and it also commonly referred to as list comprehension statement. Okay, so it's a very terse, single statement feature in Python, and so it's used to derive a new list, create new list from another list or a string. Sometimes this statement can be very simple, and I guess we will see some examples of these statements today. And sometimes they're super simple and it's really great, but sometimes it can be getting pretty long and complicated, so it can be a bit hard to understand, and I use my own technique to break it to multiple lines and add comments as much as possible just to explain what is happening there. But nevertheless, Python programs use of list comprehension is highly popular. And this feature alone could be the driving force of Python language popularity, I would say. So before we continue, let's take a look at a couple of useful helper functions. Okay, so there is an ORD, which stands for ordinal number function, which returns the Unicode code for a character. So basically, the way it works is that you take a character. For instance, here I use space, right? So there's like single quotes. In between, there's a space character right here, one single space character. And I say, okay, what is the ordinal Unicode value? So Unicode is a character encoding which starts with the 0 and goes like 1, 2, 3, 4, 5, and each corresponding code represents a specific code. Okay, so Unicode, like higher numbers in Unicode represent international characters, and there's this encoding that all of the environments, like all modern operating systems, understand how to convert characters to like characters in different natural languages. Okay, and so this ordinal function allows us to specify the character and obtain the code. So we simply print the code. So in fact, let's clear screen and run this program this time, right? So it's called comprehension. Okay, just simply copy and paste it here and run it. Okay, so here we get 32. 32 is a decimal value of a space encoding. So the space is encoded internally in text when you store it in a file as decimal value 32, and when you display that text, it will be shown as a space, but its internal value is 32. Okay, so the value type, the type of the value returned by ordinal is integer, and if we just take this space character, convert it to the code, to Unicode, right, and then use chr function, which takes the Unicode and it returns the character that represents the specified Unicode. Okay, so if we then test what the character of that Unicode type is, it is again converted to a string. So in Python, we don't deal with individual character data type. All characters are represented inside a string. So just a quick sort of like, a walk through these two functions. So they're very useful helper functions when we work with the ranges of characters, with individual characters, their encodings. Sometimes there's work that can be done on individual characters, and these functions are quite useful. So our next example, 832 here, is dealing with a Python code to generate a string with lowercase alphabet, containing just the alphabet, which is lowercase. There's actually lowercase constant built into the string data type itself. You can obtain it directly. But here I'm trying to experiment with the syntax of our list comprehension. And so this is a nice example where we can say something like this. So first of all, let's use some code to generate a string with lowercase alphabet, which is, by the way, shown right here, right? So this is our the ending result of this section here. And we say, let's start with an empty string. And then we say, inside the loop, right? So we have like one character, I call this variable one char, in range from ordinal A to ordinal Z plus 1, right? Because the range function stops at the last value, so we need to use plus 1 to go one step beyond lowercase z, so that the z in itself is included in our output, right? So it's right here, it's present. So this is the correct range that we want. And inside this loop, notice the indentation, of course, loop requires indentation. And we just simply use concatenation assignment, and we say, okay, let's take this one char, which in a range returns a list of integers, and we pick one character from that list, and we convert it to a character, and we append it to our string, and we just simply print it, and we get this output of our alphabet, lowercase character alphabet, as specified here. So this is an example of a simple loop which does not use comprehension. Now, exact same process using the comprehension syntax. And I actually want to show you that this is that like sort of like one-line statement, okay, which does exactly the same thing. And you can see that all the elements which are present in this original attempt to use a string and generate this alphabet are present in this new syntax. So we have, for example, one char is right here, right? So one char for one char in range, the same exact loop, right? So if I highlight it, you can see that my source editor highlights both of these for loops exactly the same way. And the way that this comprehension syntax works is that you take this variable outside, like a prefix in front of this loop, and say, well, you know what I want is that this is some sort of expression which will generate something that I would like to use in generation of my list. And as long as this loop executes in its own range, right, I get a sequence of values, and I actually convert them to a character, and this is what I would like to get. Okay, and so here essentially this is what this comprehension does. It creates a list, and notice that the entire statement is enclosed in square brackets. So the end result is always a list, and I call it alphabet list. Okay, so this is alphabet list. Let me resize it again, and you can see that when we print this list right here, okay, when we print this list right here, we get all familiar, single character list of individual characters, and clearly this is a list of these. This is a long list of individual characters, those that we wanted, okay? But when these comprehension statements or list comprehension syntax gets very long, and so in the kind of horizontal style of coding, it's very difficult to read. You see, even with this, what I have right now, I need to scroll to see the end of it, and it's like, it's difficult to deal with. There's perhaps a better way to organize the syntax is to use, like, it's the same thing that I do the second time, but notice that the second time I have comments, I put things on separate lines, I have more comments, and I have this expression at the top. I have this loop, which creates every single element. And from that single element that is present right here, I build my list, and I decided to convert it to a character, right? So right away, so if I didn't have the CHR here, I would be building a list of integers. But with CHR function call, I convert integer to a character, which in itself, of course, we already mentioned, is represented by a string. In addition to this, when you construct your comprehension statement, you can also have optional conditions. They're optional because you don't have to have them, but if you want, we can say, how about we exclude a character, right? So we say that as long as this one character is not the same as ordinal y, we should be excluding y from this list. In fact, let me save this program, right, and just run it one more time. So right now, it's the same statement, right? So I really don't have to comment it out, but I can comment it out right now, just to make sure that everything is done just in this and in this the latest comprehension statement, right? So I just said I don't want character y in here, right? So the original one, of course, includes it, but if I rerun it again, you see that now it's being right here. Example, in our example, it's being excluded from the list. Okay, so this time, so 832, 833, here you can see that also character y is not present here, so this is the output from here. And when we generate it, so the character y is excluded. What's interesting about the syntax, and it's a little bit like, it's sort of like declarative. It's not like you execute this loop on your own. It's like declarative syntax that tells Python, this is what I want. I want this expression, which should be processed as a result of executing this loop. And optionally, I can specify also conditions or declare these conditions that I want to be true in order to, to skip some values. So here I can add just another if statement, just like this. If one character is not the same as X or is not the same as Y. So if I repeat this again, let me clear this to make everything clean, right? So, yeah, and first I need to save this program. So let's do it again. Okay, so one more time. So you can see that now both X and Y characters are excluded from the resulting list. Right, so this is the nature of the syntax, and I tell you here that there are some really great tutorials that talk about list comprehension in both W3 Schools and Tutorials Teacher that you should definitely take a look at because the list topic is big and has lots of features, but list comprehension is a little bit more abstract, and that's why I'm not repeating other features of list a lot, but rather trying to focus on list comprehension for the rest of our videos here, right? So this is what we've got, and our a couple more things here. You may be wondering, okay, if I have a list of individual characters, just like this, right? So these are all strings that contain these single characters in them, right? So we print this. How would you convert such list to a single string? If you say, oh, I have a list of strings, now I would like to have a list. I'm sorry, I would like to have a single string. So the join function right here is a member function of a string, and you can actually do it. It's kind of cool. You can just like start with the delimiter and say, using this delimiter, I would like to join all strings on this list. So this join is super helpful function, which, like, you can just like convert little bits into a single string and format it. It's really working super nice. Okay, the only precondition that this alphabet list must contain only string elements. You cannot have integers there. There will be no automatic conversion. And if you have something that does not look like string in this alphabet list in our example, you'll get an error. There will be a type error. It'll just say, I cannot do this. But as long as they're all uniformly strings, you can do it very nicely. So we can, for instance, like use like a dash, right? Like a minus sign here, and rerun it again to see what kind of result we get if we get a little different string here being used as a delimiter when converting it all to string. Okay, so I already saved the program, so I rerun it. So here, right, so we've got this like this list. X and Y were excluded because we tried to use these optional conditions, and now we also use this like dash character. You can just use anything you'd like as this delimiter, any kind of string to define it. But it's really nice and interesting feature, very like that adds a lot of flexibility to interaction between list of strings. And if you want the final product as a string, you can do this join with the delimiter. If I didn't want anything, then I just use like dash character. And our final example here, like this output here, 835, shows us that if we want to hold on to the string returned by join, then we can simply assign it to the variable name, right? So we can just say, all right, so let's just have back our alphabet. And again, I'm using this empty string. I say no delimiter, just join this entire list of alphabetical lowercase characters right here, and print. As when I print it, I still get this, but of course, originally the list excludes X and Y. That's why X and Y are not present here, but this is just the result of our experimentation here. So this is our first look at list comprehension, syntax, and it's really a Python statement, and it's enclosed inside square brackets. And again, starts with some sort of expression, which is derived from a for loop, specifically for loop, which right here it's present, right? It's part of it, and which has its own range to run through, and optional conditions. So these conditions don't have to be present here, but often they are present. And you can see that it starts with square bracket and ends with square bracket. This inside is our comprehension statement, and the result of it is a new list. Okay, so we get as a result of using it, it generates a list of something that we would like to have as a result of this statement.